Welcome everyone to Crash School Global. Today our topic is intrinsic and extrinsic semiconductor. So we have know about the types of semiconductor which are intrinsic and extrinsic. But what is intrinsic and what is extrinsic and how it works? So today I want to show you how to work how the intrinsic and extrinsic semiconductor is working. Okay, the first one is our intrinsic semiconductor. I write there, this is intrinsic semiconductor. And in intrinsic semiconductor, the purity of the semiconductor is 100% accurate. In periodic table, we know we get there some semiconductor which is silicon, germanium or gallium. So those are the semiconductor are 100% pure because we do not add any impurity to this semiconductor. So these types of 100% pure semiconductor is called intrinsic semiconductor. And there is a very good example of intrinsic semiconductor which is our silicon. So here I write a structure which is about the silicon lattice structure. You may see there the silicon is connected to each other by using their covalent bond. And in a pure semiconductor, there are only 4 electrons at the outer shell of each of the semiconductor. So here each of the silicon contains 4 valence electron in the outer shell of its atom, and these 4 electrons can easily share the electron to another silicon semiconductor and also make the covalent bond. Okay, so here is our silicon, and these 4 electrons are combined to each other by another silicon semiconductor. Okay, here this 4 is our outer shell electron of a silicon, and this silicon is actually too much pure silicon. There is no impurity because I do not show there any impure material like boron, arsenic or antimony. So here this silicon, central silicon, can easily make the covalent bond with the another silicon, and here they share only 2 electrons to create the covalent bond. So this is our another silicon, this is our another silicon, and this is our another silicon. So there are 4 silicon which is surrounding the central silicon, and this central silicon can easily make the covalent bond. There is no another silicon is another types of material is connected to this lattice. So if you count here, each of the element is silicon, and there is no another extra material which is called impure material. So this is the example of one kind of intrinsic semiconductor, and I repeat this again, in an intrinsic semiconductor no other metals are connected or attached to each other, only the 100% pure same material is connected to each other. But in case of semiconductor, those material are connected to each other by using a covalent bond, and in a covalent bond the electron is shared. Okay, so this is our intrinsic semiconductor, and another types is our extrinsic semiconductor. So this is our extrinsic semiconductor. So in a extrinsic semiconductor, the impure material are connected or attached to the intrinsic semiconductor, and when we connect this impure material, the system of connecting the impure material to the pure semiconductor is called doping. So doping is actually one kind of system which we have used to make the extrinsic semiconductor. So extrinsic semiconductor is not pure, it is also impure, and intrinsic semiconductor is 100% pure. So we get this intrinsic semiconductor from our periodic table, but if we want to get the extrinsic semiconductor, then we can add some impure material plus intrinsic semiconductor. So when we add some intrinsic semiconductor with some impure material, this is called our extrinsic semiconductor. And there is another good thing, the good point, that which is doping. So doping is actually the process which can convert the extrinsic semiconductor into intrinsic semiconductor. Okay, I think I make a mistake. Doping is the system which can convert the intrinsic semiconductor to extrinsic semiconductor. Okay, so there is another very important point, that is which is the impure material. This is the question, that which type of material that we have used to make this extrinsic semiconductor. Suppose in this impure material we do not add another material, we do not add the material which is not available on our environment, or we cannot add any types of material by our wishes. So we can only use the two types of impure material. The first one is our trivalent material or atom, and the second one is our pentavalent. So why I use these two types of thing? Because our real or pure semiconductor contains only four electrons, valence electrons. So these four electrons, because of these four electrons, the intrinsic material of any semiconductor and intrinsic material of semiconductor is called as tetravalent material. So silicon is our tetra valent material. So we only use the material which is trivalent. Trivalent means the material which contains only three electrons at the outer shell of its atom, and pentavalent means only five electrons contained at the outer shell of the atom. If we apply these types of extra impure material to the intrinsic semiconductor, then the conductivity of the semiconductor is increased. In the 100% pure semiconductor, we do not flow the current 100%, or we do not flow the electron 100% accurately. But when we add some impure on this intrinsic semiconductor or pure semiconductor, it can easily increase the flow of current, it can easily increase the flow of electron. So this is very important point, that if we want to get the exact or the real semiconductor or a good quality of semiconductor, we have to make doping system, and in this doping system we converted this intrinsic semiconductor into extrinsic semiconductor. Now there is an example of trivalent and pentavalent molecule which is which we can get. So the trivalent molecule or atom is suppose boron and aluminum, because boron and aluminum contains three electrons as in its outer shell of the atom. So the valency of boron and aluminum is 3. Okay, and pentavalent example is our antimony or arsenic. So antimony and arsenic contains 5 electrons at the outer shell of its atom. So antimony and arsenic is very good example of pentavalent molecule or pentavalent atom. So in this when we add boron or aluminum to the intrinsic or pure semiconductor, then the conductivity of the semiconductor is increased, and also we use this device in our electronic system. And when we add some pentavalent atoms to this pure semiconductor, then there is a good quality happened, and this good quality maintains how this types of material is working as a electronics device. Okay, there is another thing that about intrinsic semiconductor. If we apply some heat to this pure or intrinsic semiconductor, then the electron which creates the covalent bond between each of the silicon atom can easily vibrate, and also they can flow, because when we apply some heat to this intrinsic semiconductor, then this electron gets some energy from the outer environment in terms of heat, and then this electron can easily pass from one atom to another atom. So the conductivity character of this silicon semiconductor is increased because of applying the heat. So in intrinsic semiconductor we can easily gives the heat, and also flow the heat, and also make the semiconductor very much helpful conductive, very good conductor. But in case of extrinsic semiconductor, we do not apply any heat, because when we apply the impure material like trivalent or pentavalent material to this pure intrinsic semiconductor, then the conductivity of the material is increased. In that case we do not apply any heat to extrinsic, but we have to apply heat on intrinsic so that the conductivity of the electron or conductivity of the current is increased. So we have to I want to share another thing, that is temperature coefficient. The temperature coefficient of a semiconductor is positive, so I want to write this: temperature coefficient of semiconductor is positive. Why positive? Because when we apply heat on a pure intrinsic semiconductor, then the flow of electron, the flow of current is increasing, so the conductivity is also increasing. So when we apply heat, then or when we apply the temperature, then the conductivity is increased, so the temperature coefficient of silicon semiconductor is positive. But in case of conductor, what is the effect? If we apply the heat on a conductor, then the free electron of the conductor achieve this heat, and also they cannot flow the current or electron very smoothly. In that case, the temperature coefficient of conductor is negative. So when we apply the heat to a pure semiconductor, the conductivity is increased, and in that time, that's why you can say the temperature coefficient is positive for semiconductor. But in case of conductor, if we apply the heat, then this heat actually makes some obstacle to the flow of free electron. In that case, the conductor's temperature coefficient is negative. And the last thing that I want to share with you, this is the amount of impure material. So in doping system, we have to use some impure material to intrinsic semiconductor so that it will going to be extrinsic semiconductor. But when we add this impure material, the amount of this impure material is too much low, so we must maintain the too much low amount of impure material. Suppose I have 10 lakhs or 10 million, suppose I have 10 million silicon here, 10 million silicon atoms, but I only use 1 to 10, only 1 to 10 impure material like boron, 1 to 10 atom boron, or 1 to 10 atom aluminum, or 1 to 10 atom, I think this is arsenic or antimony. So when we apply any impure material, then the amount should be very much low. Suppose 10 million silicon, in this among this 10 million silicon, we only use 1 to 10 atom of impure material. So this is very important point of doping. So these are our all about our lecture, and I do not draw any extrinsic semiconductor lattice. I will draw it when we will study about p type and n type. And what is p type and n type? If I want to tell you in a short form, that is when we apply the trivalent impure material to any intrinsic or pure 100% pure semiconductor, it is going to be p type material. And when we add pentavalent any impure material to intrinsic semiconductor, it is going to be n-type material. So I will discuss it later. So now I want to show another thing. This is the people who are watching our videos, please subscribe and also share our video, and also you can press the bell icon of our YouTube video channel so that you will get our new videos notification on your laptop or mobile phone. And also the people who are using Facebook, Instagram or Twitter, please upload the status which is about hashtag Crash School, so that I will find out you, I will find you and also directly communicate with you. And also you can visit our website, which is thecrashschool.com. Here you will find the vast topic about the engineering sector, and also you can learn from here the university course and also engineering course. So please visit thecrashschool.com. Here you will find the option which shows you how many subjects that we provide you, which is totally free in cost. Okay, so please use hashtag Crash School on your social media, and also don't forget to subscribe our YouTube channel.